So we're going to look at lesson 6 a little bit differently. In your student manual, there's an opening exercise that has A, B, and C. It actually looks like this. I skipped it. It's here. We're going to skip that. We're not going to do that. It says find the following quotients and write the quotient in standard form. We're not going to do that only because this opening exercise is not a lot of fun. We're going to focus on this. We're going to use this section a little bit differently. Now, this is not in your notes. I would recommend you pause this video for a minute and copy these things down. This is a section where we're going to focus on special factoring identities. In other words, the difference of squares, difference of cubes, and sum of cubes. You're going to want to know these three. So you're going to want to spend some time getting familiar with them, being able to know when to recognize them, so that way you can take advantage of them throughout the course, because they do come up now, later, towards the end of the semester. These things tend to come up frequently. So what I'm going to do is I'm going to model each one, and then I'm going to show you how to take advantage of each one. So in this design, if we look at the difference of squares, it's kind of obvious to see what we're looking at. We have an x squared minus an a squared. And so that factors into x minus a times x plus a. So I'm going to model one with an example, right? So we have an example of x squared minus 9. This is a difference of squares. How do I know it's a difference of squares, right? Well, I know a little bit about 9. I can rewrite this 9. So it says x squared minus 3 squared. Notice how it matches the pattern up top. This x obviously serves as the x value, and the 3 serves as the a value. So that means if I want to factor this or break this up, I'm going to put an x minus 3 in the first parentheses, and then an x plus 3 in the second parentheses. That's a difference of squares. Again, note how I broke this 9 down into a 3 squared. You're going to utilize this a little bit later in the problem set to help you solve some of the problems. Next up is a difference of cubes. Same idea. It says x to the third minus a to the third. So when it's broken down, it breaks down into x minus a in the first parentheses, and then x squared plus a times x plus a squared. So if we model this, this is an example of a difference of cubes. And so if I was to rewrite it, it would say x to the third power, and it would say minus 3 to the third power. 3 times 3 is 9, times another 3 is 27. So that's how, again, I make this appear as the x value and then the a value that we're going to use to write our identity factored out. So now that means we would write x minus a, which turns out to be x minus 3. And then we would write x squared. We would write plus 3x. And then we would write plus 3 squared, or you could just write 9 in that given case. The last one is the sum of cubes. So same idea. We take a look at it. X to the third plus a to the third. This is going to break down into x plus a. Notice, we'll take a moment here. Notice the difference between this one and this one. One of them has an x plus a in the front, the other one has an x minus a. It goes with the one that matches, whether it's a difference of cubes or sum of cubes. So what is the difference between the two patterns? Well, that's what we're going to investigate and look at. So if I was to rewrite this, and this is something I recommend, a step that I like to see students write, it would be x to the third and plus, and we write this part right here, 2 to the third power. 2 times 2 times 2 would be 8. So that means when I look at that, I know exactly what my x is going to be that I'm going to use and what the a is. So now we would write x plus 2, and then we're going to write x squared. Notice this time we're going to write a minus 2x, and then 2 squared we would write a 4. this is our sum of cubes. These are the three special identities you need to focus on, and what we're going to look at in the next several examples and exercises is pointing out these three identities and taking advantage of them. So we're not going to follow the directions exactly as is. So like in exercise number 1, it says use the patterns to predict each quotient. We're going to take advantage here of the difference of squares, sum of cubes, and difference of cubes. It also says explain how you got your prediction, and then test it by applying the tabular or reversed. We're not going to do this part here. We purely want to focus on identifying the difference of squares, difference of cubes, and then sum of cubes. So like if we look at this is x squared equals 144, right? So I can rewrite this. And again, I'm showing this step for understanding. I could rewrite this as minus 12 squared over x minus 12. Now that makes this a difference of squares. So I can rewrite this as x minus 12 and then x plus 12. And then of course that's going to be divided by x minus 12. So what I get to take advantage of is that this one gets to cancel this one. And so then my final result is x plus 12. Right? That's me taking advantage of the understanding of what a difference of squares looks like. So let's look at part B. Part B is a difference of cubes. So if I look at that, I can rewrite this as x to the third power minus 2 to the third power over x minus 2. So that means when I do the difference of cubes, I'm going to have an x minus 2 in the front. Then I'm going to have an x squared plus a 2x and then plus a 4. Remember that pattern, right? We'll re-illustrate it. It should say x squared plus ax plus a squared. That develops that particular piece. So now we draw our divisor bar, we put our x minus 2 at the bottom. And so what we get to see is that this one and this one cancels out through division. And so our result is x squared plus 2x and then plus 4. Right, again, our focus here in this lesson is to take advantage of the three identities that we talked about on the previous slide. Again, if you have not written those down, now might be a good time to rewind the video and write them down. Or if you want, they're at the end of your lesson summary in this section as well if you want to look there. So now let's try it again, right? So we're going to have x to the third power minus 5 to the third power. And so here we have x minus 5. That means if we were to factor this out, we would end up with an x minus 5, then an x squared plus 5x, and then plus 25. 5 squared. We draw our divisor bar. We put our x minus 5. This one gets to cancel with this one. And this becomes our answer. Now, because I'm only focusing on this and I'm altering this lesson, we're only going to focus on those identities. We're going to skip letter D for this particular lesson at this time. And so that takes us to example number 1. What is the quotient of this one? We're not going to use reverse tabular here. So again, we'll just draw a line through this. We're not going to focus on that. We're just looking at those identities and to recognize them and take advantage. So we see that this is a difference of squares. So that means I can factor that into x minus a, and then x plus a, that's divided by x minus a, and so this one cancels this one, and then our final result is x plus a. Final answer in that particular design. Right, so the same idea plays out. What if we had a difference of cubes and well, we'll talk about b in a minute. But let's say we talk about the difference of cubes, right? Just remember how, and this is a good mental exercise, see if you can remember how to factor that out. So if you won't, pause the video and do a little mental check. But we would write x minus a. That means this would be x squared plus ax plus a squared. That gets divided by x minus a. So that means this one and this one are allowed to cancel out. And so the final answer is x squared plus ax plus a squared. So b is different. B, you might look at it and say, well, wait a minute, you didn't give us a difference of fourth roots. But if I have an x to the fourth power, here's the unique idea, is I can rewrite this as x squared squared. And then I can rewrite this one as a squared squared. This is a power raised to a power. 2 times 2 would be 4. And so this is an equivalent version of that design. So what I have done is I've taken something with fourth powers and I've essentially turned them into a difference of squares. To whereas now when I write this one, I would write x squared minus a squared times x squared plus a squared over x minus a. Again, our goal is to try to simplify this as far as we can. So by doing that, I created another difference of squares here. So I write x minus a, and then x plus a, and I still got that x squared plus a squared there on the side. And then that's over x minus a. This is where we can now cancel. This one cancels with this one. And I'm left with a multiplication problem where I could do the distributive property, or I could draw the area model. But x times x squared is x to the third power. X times a squared is a squared x. And then I go to here. This is a x squared, and this is a to the third power as that particular answer. That answer is acceptable, or if you wanted to pick a variable like x and have them in descending order, you would write it like this, x to the third power, and then I would move this one because it's squared. Next in line, since this is linear, I would put it next. So it would put plus a squared x, and since that one has no x's, and I would put that one last. Ultimately, it doesn't really matter. That's just an option for you to consider in that design. So there'll be, one more really slide to kind of look at. They say to try to predict without performing division or divisor to know what type of remainder you would get. And so remember, this is a difference of squares. If you think about that, a difference of squares breaks into x minus a and then x plus a. So that means if we divided it by x plus a, like that, these would cancel. And so my final result would be x minus a. This one here is a difference of cubes, right? So the interesting thing with this one is if I factored this out, it would say x minus a. And then I have x squared plus ax plus a squared. Well, when I attempt to divide that, these two don't match. So I cannot divide x plus a into that problem at all. There would be a remainder that would be involved. And again, we're not going to deal with remainders. We're going to look at that at another time. So x plus a is not divisible into that one. This is a sum of squares, right? There is no process right now for doing a sum of squares. So for this one, we're simply going to say no solution. We're going to come back and address, we're going to add something called a sum of squares later at the end of module 1, but that's not for today's discussion. Here's our sum of cubes, right? X plus a, and then x squared minus ax plus a squared, and then we have our x plus a, and so this one cancels this one, and then you get x squared minus ax plus a squared would be the result for that one. Exercise 4 we're not going to look at. It's not necessary for our purposes. We are focusing on these three identities right now. And so again, I take you back to this slide that we started with, the difference of squares, difference of cubes, and sum of cubes. These are the ones you need to focus on knowing and being proficient in, because they will come up in assessment and other problems throughout the course, where if you don't recognize them, you'll find yourself getting stuck. So I would go ahead and invest the time doing so now. All right, so that's the end of lesson 6. Now it's time for the problem set. And if you have any questions, let me know.